Okay, welcome back everyone. Going to really quickly here go through the various steps for factoring, just the kind of things we look for. Again, this should all be review. If you have questions, of course, you can try to clarify them, but this should hopefully just refresh your memory if you had a pretty good idea of what you're doing to start. So, first thing I always look for, common factors. Regardless of the form of the question, if there are common factors, start by taking them out. So when we look at this one pretty quickly, I think you'll see each number here is divisible by 3, and so that'll be a common factor. Each term also has at least some x's and some y's, and so our common factor will have a 3, in this case 1x because there's only one x in the middle term, and 1y here. What we're left with in the second brackets, so you want to remember that what we're doing in factoring is basically the reverse of multiplying. Some people sometimes say dividing out, but really what we're doing is factoring. It isn't exactly the same thing. So we're factoring out the 3, the x, and the y. That means that the first term still has a 3 and an x, the middle term still has y squared, and the final term has 7x squared. Of course, if I do multiply this through, I should get my original question. Now the order in which these appear might differ for you than for what I've got written down here, but of course you just want to be able to recognize the various forms. So what I call simple trinomials, that is an x squared followed by a certain number of x's followed by a certain number, 1, 2, 3 pieces, make it a trinomial. And our basic rule is we find two numbers that multiply to the value c and which add to the value of b. If they're negatives, that's fine. X squared plus 6x plus 8 is our example here. So we need two numbers that multiply to the 8 and add to the 6, positive 4 and positive 2. They go directly into the brackets. So again, that's the factored form. If we were looking for an actual solution here, it would be a little bit more, but for now we're concentrating on the factoring. Next common form that we see, difference of squares. That is, there's a squared value minus a squared value. Difference, of course, means subtraction. Squares means two things that are squares. And essentially, again, pretty simple. I went with a very simple example, x squared minus 4. What starts our brackets is the square root of the first term. So the square root of x squared, the square root of x squared is the x. The square root of the 4 is 2. One is added, one is subtracted. Okay, the same would hold with any other similar type example. So if I had something a little bit fancier, 4x squared minus 49, the square root of the first term is the 2x. It will start my brackets. The square root of the second term is the number 7. It will end my brackets. One is added, one is subtracted. Now really where people tend to get hung up is in the fourth option here, what I'm calling complex trinomials. So essentially anything that has not just x squared by itself, but some coefficient followed by the x squared. 6x squared, 2x squared, 4x squared in the example shown. And what we're looking for then is the value that we want to multiply these two terms a and c, determine what that value is, and then we need to find two numbers which multiply to that same product. It may not be the exact same two numbers as a and c. It can be, but it doesn't have to be. And then the two numbers have to also add to the value of b. So we'll look at the example here. We have a 4 and a 7. 4 times 7 is 28. So we need two numbers that multiply to 28 and that add to negative 16. Okay, so that's what it says here. Of course, those two numbers are negative 14 and negative 2. And so we split the middle term. And then as the instructions will tell us, so we can just get rid of that, we then look to find a common factor between the first two terms and between the second two terms. So between the first two terms, the common factor is 2x. Factor out the 2x, and I'm left with 2x from here and minus 7. Over here, the only thing that's common is 1 or possibly negative 1. And as a rule, if there is a negative, it's probably going to come out. So the negative 1 is my factor, my common factor. 2x minus 7 is what's left. The brackets must be identical at this point in time. If they are, I tend to pull them out front, and what's left is the 2x here and the minus 1 to complete the second bracket. What we're doing here really is we're taking a common factor of the first half of the expression and the second half. So the 2x minus 7 is a factor of this first part, is a factor of the second part as well. Okay, so that's one method, call it option A here, for factoring complex trinomials. Not everybody does that, and again, I don't know which method you've learned, but whichever you're more comfortable with is fine with me. The second option is to treat it more like a puzzle. So complex trinomials, again, same question. And here's the logic behind what we're doing. Now, you can sort of skip or ignore the answer for the moment being. We'll kind of get to it. But basically what happens is if we have the final answer, or if we have two binomials multiplied, the first term in the first bracket times the first term in the second bracket is what determines the start of our trinomial. The last term, or the second term in each bracket, multiply to give me the last term. And so that's what this sort of says. Again, a little convoluted perhaps. We know that when we factor something like this, A is the result of multiplying the terms that start the brackets, and C is the result of multiplying the terms that end the brackets. So continuing with some logic here. Here, since A has to be a 4 and C has to be a 7, we can quickly narrow down the various possibilities for the start of our brackets and the end of our brackets. Our bracket will start with a 4 and a 1, or with a 2 and a 2. Those are the only two options to multiply to get a 4. They will end with a 7 and a 1, or some combination. Again, negatives are possible here as well. But basically, knowing that the two numbers have to multiply to 7 means I can eliminate pretty much all I can eliminate all other numbers other than a 7-1 combination to finish my brackets. And then really what I'm looking to do is just kind of a trial and error sort of, let's figure out which ones work. So you sort of think about the 4 and the 1 is one possibility, and again the 7 and the 1 to end the brackets is the only other possibility. And so 4 times 1 would give me 4, 1 times 7 would give me 7, and so I'm wondering, does a 4 and 7 add up to the negative 16? Of course it doesn't. So other possibilities would be the 4 times the 7 and the 1 times the 1, again to sort of get those numbers that add up to the middle here. Clearly 4 times 7, 28, and 1 times 1 is 1. Those two numbers don't work out to add up to the 16 in the middle. So if I think, then I'm going to have a combination of 2, 2 and 7, 1. If I multiply 2 times 7, I get 14. 2 times 1, I get 2. And 14 and 2, if they can both be negative, will add up to the negative 16. So what that means is I will start my bracket. Sorry, I have my pencil upside down here, that's why it's not working. I will start my bracket with the 2's, 2x and 2x. I will end my bracket with the 7 and the 1. And then in order to make sure I get a negative value in the middle, I'll need to have negative 2 and negative 14 when we multiply them through. If these numbers were different, we just have to be careful to make sure, whatever number I determined should be multiplied by the 7, they go in opposite brackets to ensure that we get that multiplication. A good rule of thumb, if you're using this, is once you have your answer, take the extra 2 seconds and actually multiply it out. Make sure you're getting your right answer and you didn't get confused along the way. Okay, so this is a method that some people use. I'm not advocating it specifically. I kind of like it, but I'm fairly comfortable using it as well. If you're more comfortable with the other method, I think it's more likely to get you the right answer every time. It takes a little bit longer, obviously, or at least takes a little bit longer on an easy question. If this question got to be quite complex, 48 times 96, and we had to list off all the different possibilities there, or sorry, 48 and 96 as the two numbers, the other method might actually end up being easier. So essentially your job is to make sure you get the right answer. And then basically this just says what I just said. We have to test all possible pairings to see which one might add to the negative 16. If I multiply the 4 and the 7 and the 1 and the 1, the 4 times 1 and so on, this is the only one that actually gets me numbers in the neighborhood of negative 16. I think I have one last thing. Okay, so yeah, so here we need to be careful. We need to have negative 14 plus negative 2 as our two numbers, so they do have to be negative. Last thing I sort of stated here, if you happen to have an expression with 4 terms, it doesn't come up often, but it certainly does happen. Still common factors first. Always look at the common factors regardless of the rest of the question. All that ends up doing is you take bigger numbers out, you start working with smaller numbers. But if you do have 4 terms specifically, consider trying to group them the way we did in 4a. Okay, so the possibility would be, just a sec here, if we had something like this line from the start. So we have 4 terms, not necessarily in that order. We could rearrange them if we needed to, but if you have that, we don't have a complex trinomial, we don't have a simple trinomial. By having 4 terms, we've eliminated basically all of the regular methods we've seen, but there is that possibility that we could be sort of halfway through a complex trinomial question, group these two, and just see, do you end up with the same value in the brackets? If you do, finish it up the same way we did here. Okay, so again, not something that happens all that often. We may see some this year. I can't guarantee that we do or don't, but that's kind of the one method we have aside from common factors, that if there are 4 terms, we might be able to simplify. So I'm going to call that the end of the video, and I'll give you a chance to try some of the review stuff. We'll learn some new methods this year, so hopefully we can get these ones down pretty solidly before we try to do something a little bit more complex.